Alright guys, so in this video we're going to be looking at non-linear equations, right? And we're going to look at how do we interpret them, how do we analyze these type of problems in order to find the solution, alright? And so we're going to be working with this problem right here, and before we actually read the question, guys, remember we always want to look at this equation first, alright? So this equation tells us that h is equal to negative 4.9 t squared plus 25t, alright? And this is a lot different than what we're used to. We're used to having, h as a function of t, but we're used to having some sort of constant rate of change and some sort of initial value, alright? And in this equation right here, there's no constant rate of change, right? Because there's a t coefficient here and there's a t coefficient here, right? So there's no constant number. So it's important to look out for things like that. But what do we know so far about this? Well, we know that the shape is going to look a little something like this, right? And we know this because we have a negative 4.9 t squared. So a regular t squared would look something like this, right? And that's how an x squared would look like. That's our little parabola right there. And if it's negative, it would just go the opposite way like that, all right? So we know that about the graph so far. So we know it's going to hit, the x-axis at 2 points. It's going to hit it, maybe once at 0. It's going to hit it once at some other point right here, and we know that it has some sort of maximum value right here, all right? So that's what we know about it, all right? So let's read the question now. It says the equation above expresses the approximate height h in meters of a ball t seconds after its launch vertically upward from the ground with an initial velocity of 25 meters per second, all right? So let's start underlining things. This is h height in meters of a ball t seconds. Be careful not to cross it out. T seconds after it is launched vertically upward from the ground. Alright, we don't need to underline that stuff right there. T seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second, right? So that's how fast it gets launched up. After approximately how many seconds will the ball hit the ground, alright? And let's underline this wording right here, ball hit the ground. What does it mean when a ball hits the ground, right? Well, it means that the height is going to be 0, right? Because it says h is a function of t and h is the height, and h is 0 when the ball is directly on the ground, and as t passes by, the ball comes up, 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 and then it hits the ground again at h equals 0, all right? So this is the h axis right here. This is the t axis, so h is going to be equal to 0 when the ball hits the ground. All right, and so what that tells us is we can set h equal to 0 right here and solve for t. All right, it's because it's asking us how many seconds. In other words, solve for t. All right, and that's not a difficult task for us to do. All right, so we'll say 0 is equal to negative 4.9 t squared plus 25t. All right, and so now we're running into another problem. This looks a little bit funky, right? How do we do this? Well, all right, and I want you guys to write this down on your notes or something like that. But a key to solving these type of quadratic equations, I guess you could call them, is to factor out. All right, factor. That is a key. That is a key idea. Factor, right? And so you can only factor when you have common factors, right? And the common factor here, we have negative 4.9 t squared plus 25t, all right? So we can see that the common factor is this coefficient t. So we can bring it outside our little parentheses. So we have t, and then we can rewrite it as this, 4.9 t plus 25, all right, is equal to 0. Alright, and this right here is basically the same thing as this up here, except for we just took out a t, alright? So, what would t equal in this little equation right here in order for it to equal to 0, alright? Well, an obvious one is t equals 0, then the whole thing would equal to 0, right? Because anything times 0 is 0, so t can equal 0. Let me write it up here. T can equal to 0. But we see t is equal to 0 is not an answer choice right here. So we're gonna have to find what value of t makes this little parentheses thing equal to 0. So that's not a very difficult task. We can say negative 4.9 t t is plus 25 is equal to 0. We can subtract 25 on both sides. So say negative 4.9 t is equal to negative 25. And we can divide our negative 4.9 on both sides, right, to kind of isolate that t. So you have t is equal to negative 25 over negative 4.9. And in this section of the test, you'll have the luxury of a calculator, so you can just put this into your calculator, right? Negative 25 divided by negative 4.9, and you'll get some sort of value like 5.102, and then so on, right? But all we need to do is have this 5.102, and it says approximately how many seconds, right? It's not asking us exactly, it's saying approximately how many seconds. And so the answer to this, the closest one to 5.102, is our answer D right here. Alright, and so that was a little complicated, that was a little funky type of problem right here, but I just want you guys to memorize this, right? Sort of write this down in your notes. Factoring is the key to solving these sort of these exponent non-linear equation problems, all right? So remember, factor, 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 all right? And just like the linear equations, pause in certain parts of the word problem to sort of take note of what they're saying, all right? So like we did, we said negative 4.9 t squared, all right? Read the question carefully, do some practice on Mathtivity, and I will see you guys on the next video.